gang, it's Katie. Last time we turned sine waves into sound tones, chords, melodies. Today is the season finale. We're going to take everything we've learned and build one thing that uses all of it. Think about where we started. Episode 0, installing Python. Episode 1, a variable called x. Then loops, functions, our first plot. 3D surfaces, parametric curves dancing through space, polar roses and spirals, waves beating against each other, Fourier building squares from sines, and last time hearing those waves as sound. 12 episodes, one language, look how far we've come. One last script. Everything together, import numpy as np, import matplotlib.pyplot as plt from mpl_toolkits.mplot3d, import axes3d from matplotlib.animation, import funcanimation from scipy.io.wavefile, import write. Here's the plan. We're going to build an animated 3D surface, a wave rippling outward from the center, like dropping a stone in water, and we'll generate the sound that goes with it, the frequency of the wave, as an audio file. Visuals and audio from the same math. The surface needs a grid. X equals np.linspace of -5,5, 200, y equals np.linspace of -5,5, 200, capital X, capital Y equals np.meshgrid of x, y, r equals np.squirt of capital X squared plus capital Y squared. R is the distance from the center. Every point on the grid knows how far it is from the origin. That's our ripple variable. The wave itself, def wave of RT, freq equals 3, decay equals R plus 0.1, return np.sin of freq times R minus t divided by decay, sine of R minus t, that's a wave traveling outward, divided by decay, it fades as it spreads, just like real ripples. The further from the center, the weaker the wave, and t shifts the phase each frame, so it moves. Set up the figure, fig equals plt.figure, ax equals fig.add_subplot, 111, projection equals 3D, then the update function, def update of frame, ax.clear, z equals wave of r, frame divided by 5, ax.plot underscore surface of capital X, capital YZ, cmap equals viridis, alpha equals 0.8. Frame by frame, the ripple spreads and fades. Now the sound sample rate equals 44,100, duration equals 3t underscore audio equals np.linspace of 0. Duration sample rate times duration tone equals 0.5 times np.sin of 2 times np.pi times 300 times t underscore audio 300 hertz. The frequency of our visual wave scaled to an audible pitch. Save it, right of ripple underscore tone.wave. Sample rate tone.as type np.int16. Run it. The surface ripples outward, fading at the edges, rotating in 3D. And the wave file plays the tone of that wave. One equation, you can see it and hear it. Visuals and audio, same sine function, different outputs. That's what I wanted you to see this season. Code isn't just instructions, it's a way of thinking. You had an idea. What does a wave look like? And you built the answer. Not by Googling an image, by writing the math, by watching it move, by hearing it vibrate. That's the power of Python. You describe the world and the computer shows it to you. One last save, cat greater than finale.python. And that's season 1. We went from 0, literally installing Python, to animated 3D surfaces with sound, variables, loops, functions, plots, surfaces, parametric curves, polar coordinates, waves, Fourier, and audio. 12 episodes, one language. Thank you for being here, all of you. Next season, we use Python to explore physics, gravity, collisions, pendulums, orbits, heat, light. The math gets real. I'll see you then.